Let's talk about even functions, odd functions, and reflections. And I guess I'm going to start with reflections. So let's say you were trying to graph g of x is equal to negative the absolute value of x. Well, I'm going to start with my parent function of f of x is equal to the absolute value of x. That looks like, give or take, something like this. And it goes to the origin. Well, what I did to it was I added a negative, and I added it outside of this function. So what I'm doing is I'm changing the sign on all of my outputs or my y values. So if you originally were positive y value, like I am up here, you're now going to be a negative y value, which means it's going to reflect it across the x-axis. Same with over here. Currently my y values are positive, so now I'm negative. So here's my g of x is equal to negative the absolute value of x. So if you had a negative on the outside, it reflects it across the x-axis, which is essentially flipping your y values. If you move on to, let's say, how about g of x is equal to negative x cubed? Well, I'm going to start with my toolkit function of x cubed. It'll look a little something like this. So there's y equals x cubed. And I added a negative, but this time you can see that negative is really inside of this function. It's inside here. So if I add it inside the function, I'm affecting inputs. Those are x values. So if my x values were positive over here, they're now going to be negative, which means they're going to be over here. And if my x values, say these ones down here, were negative, well, they're now going to be positive, the opposite sign. So you can see that I essentially reflected it across the y-axis. So here's my g of x is equal to negative x cubed. If I did that with, say, something like x squared, as in I was trying to draw g of x is equal to negative x squared, I would start with f of x is equal to x squared for my toolkit function. Ooh, totally goes to the origin and that's it, I promise. Well, if I added that negative on the inside, well, that means I'm going to change my x value. So if I'm positive, I'm now going to be negative. And if I was negative, I'm now going to be positive. So you can see that I have exactly the same thing as I started with. This is interesting to us as mathematicians, so it gets a name. So we say a function is even if your f of negative x gets you right back where you started, which was f of x. What that means visually, it's symmetric about the y-axis. What's on the left looks exactly the same as what's on the right. And you can also see that if I plug in, so I'm starting with f of x is equal to x squared. If I'm curious about whether it's even or not, you can plug in f of negative x. Anywhere you see an x, instead replace it with negative x. And if you simplify that, that looks like x squared, which is right back where I started. So you can tell that it's even by that. Another interesting trait of other functions is odd, and that's if you have f of negative x is equal to negative f of x. Those are going to be rotationally symmetric or symmetric about the origin. And odd, you could probably guess something like x cubed is odd. So you can see that what was up here, I mean, if you rotate it, it's now over there. So if you rotate it that 180 degrees, that you essentially get right back to where you started. And you can see that with, if you start with f of x is equal to x cubed, if you plug in negative x, you get negative x cubed, which is the same as negative 1 cubed times x cubed, which is negative x cubed, which is the same as, if I emphasize with some parentheses, negative x cubed. So negative f of x, so they're odd. Most functions are neither of these, so we say neither if it is neither even or odd. Not even nor odd. So for example, something like that would be if you had f of x is equal to x squared plus, say, x. You plug in a negative x, you get negative x squared plus negative x. which is the same as x squared minus x. This is not the same as f of x, because you can see I have a minus here instead. And it's not the same as negative f of x, because negative f of x would be if you put a negative in front of the whole thing, which would mean that should be negative x squared minus x, which it's also not that. So this function is neither.